make sure I did this because there's one on your test like this. On 31, you got the limit at x approaches infinity of sine 2x over x. Now, if you go to direct substitute in here, you're going to get infinity on the bottom, and we don't know what the sine of 2 infinity is going to be, so it's kind of problematic, and you kind of got to reason through this a little bit. And here's the thing. As you think about it, what is the maximum value that sine x could be, or sine 2x? It doesn't really matter what the argument is. If you think about your sine graph, isn't the maximum value you're ever going to get 1? Okay? And the minimum is going to be -1, right? So we're going to use that fact to help us here. We're going to say, we're going to take this and we're going to say, well, we can think about this way. That it's the same thing. We know that it's between, we rewrite this. Okay, here's what I'm going to do. I'm going to write this way. Sine 2x is going to approach 1, isn't it? I mean, -1 is its low value, and it's going to be 1 as its maximum value. We had this kind of a sandwich theorem way back that said that if we know our limit is between two other functions, we can assume it falls in the middle, or we can kind of figure out some things by sandwiching those values together. So if I think about it, the lowest it can go is -1, the highest it can go is 1. So the limit is going to be, I can kind of think of, it's almost like we're evaluating and thinking about what sine's lowest value could be and sine's highest value can be, and going ahead and putting it in our numerator so that we can think we know it's between these things, even though we might not know exactly what we're talking about out at infinity. We really don't know exactly where that's going to fall on that sine curve. Well, now that I've got this, here's my original problem. I know that just the top of it's going to fall between -1 and 1. Now let's direct substitute. We know at least that we could say it's between these values. Now, when I plug in infinity into the first thing here, I'll have -1 over infinity is less than. Okay, I still got a problem. Don't know what to do about this, but it's fixing to be solved. Oops, sorry, I shouldn't have put that there. It's supposed to be x approaches infinity. And then over here, I can go ahead and plug that and direct substitute in and get, put infinity here. The thing about it is -1 over infinity approaches 0, and 1 over infinity approaches 0. Oh, wait a second. Sine can, I need to kind of go back and fix something before I finish this up. Sine can be equal to -1, so I'm going to put a line under that equal sign, and sine could be equal to 1, so I'm going to put a line under that to show, yeah, it's somewhere between -1 and 1, or it could actually be -1 or 1. So actually these need lines under them, don't they? Okay. Now, I still don't know what to do about this, but because I know something about what sine approaches, I know that value is going to be sandwiched in between 0 and 0. It could be greater than or equal to 0 or less than or equal to 0, which means it must be 0. Therefore, the only thing that would work in that little equation is the limit approaches 0. So my answer is actually 0 here. Let's do another one like that, okay? At 33. Okay, so for 33, we got the limit as x approaches infinity of 1 over 2x plus sine x. Okay, so whatever this is, we kind of got two situations that could occur, don't we? We could have the limit as x approaches infinity of 1 over 2x. That sine x is going to be between 0 and 1. I'm sorry, -1 and 1. So I might have it approach. Actually, let's back up a little bit. Whatever this is, sine x, the biggest it's going to be is going to be -1. The smallest it's going to be is -1. The largest it's going to be is 1, correct? So whatever's down here, it's somewhere between -1 and 1. But the thing about it is, even if I were to add 1 or have over here, say that, let me, I guess I could write it a certain way. I could write it this way. My original limit, 1 over 2x plus sine x, is going to be sandwiched between, it could be less than or equal to, if the largest thing that sine x is going to be is 1, then I'm going to get 2x plus 1 here. And if the smallest thing it's going to be is negative 1, I'm going to have 1 over 2x minus 1. Here's the deal. If I plug in infinity in all these places, that plus 1 and that minus 1 are not going to matter, are they? This is going to be 1 over infinity, which goes to 0 down on this end. And out on this end, it's going to be 1 over infinity, which goes to 0. So whatever my limit is, if I think about doing the same thing as I did on 31 and actually writing all that out, I could kind of see it without actually doing all this actually. But it's actually also going to go to 0, because if the limit is between less than or equal to 0 and greater than or equal to 0, the only thing it could be would be 0. So my limit on 33 is also 0.